Okay. We will do some good warm-ups on Monday as well, making sure that we are practicing the different questions in the different directions. What I've noticed is some of them all, a lot of them all look very similar, and remembering what that question is asking. This particular one is asking for the multiplicative inverse. To see if it is possible, we check the determinant. So first thing I'm going to do is check the determinant. And I hope everyone heard the question earlier. Do we get any formulas on this? And you do not. So make sure that you remember your determinant formula and your inverse formula. And that's pretty much it for right now. Those are the only two things that we would have like a kind of a formula for. Make sure you remember those. A times D minus C times B. And it looks like our determinant is going to be -7. That goes to the bottom of our fraction as we are doing our inverse. And because it is a non-zero, we have an inverse. And to find that, I flip-flop A and D, and I change the sign on B and C. Question so far. And finish it out by distributing and simplifying. Negative times a negative is positive. Again, positive. Again, positive. And negative. Questions for me? Okay, today we are looking at matrix equations. You will have to do smaller ones of them by hand, so we'll talk about that. But we're also looking at the calculator side of things today. So remember, every time we do calculator problems, you want to be writing down buttons for yourself. And these are not buttons you've probably used very often. May have seen them last year in Algebra 2, may not have. So write down those buttons for yourself. Again, you are going to practice it enough that I will not be helping you with your calculator on Tuesday. My question to you on Tuesday is, do you know how to use your calculator? Okay, so make sure that you know how to do this. We are going to use this question to find some things on our calculator. First of all, how to put in a matrix, how to find a determinant, how to find an inverse, all of those things. We're going to use a 3x3, but this can be for any size, and we'll show you exactly how we do that here. Everyone have that matrix written down, please, and we are going to add to this my calculator up here. There we go. Okay, so to input a matrix, you are going to use the matrix button. Question? How did, what? Good? Okay. To get to a matrix, you're going to go to your matrix button, and your matrix button is going to be on the left-hand side, right above where it says x raised to the -1, underneath the math button. And notice it's in the little writing above, so you're going to have to hit your second key. So again, to access anything matrix-wise, you have to hit second and then the matrix button. Now, in this, we actually will usually arrow over to the edit to get started. Yours may have some little numbers written after A's and B's and such, and that just means you already have matrices in there, and that's fine, okay? But to insert a matrix, which again, maybe a note you take for yourself, when entering a matrix, you go to the matrix and you arrow over to the edit option. So we're going to arrow to the right where it says edit and pick whichever matrix you would like to edit. I'm going to edit matrix A and put all of this matrix into A. So I hit enter. The next thing it's going to ask us to do is to put in the order. Remember, order means your size, rows by columns. Ours happens to be the same, 3 by 3. So I'm going to put in 3 and 3, and you'll see that it'll give me the same size matrix that I'm putting in. All there so far? And then we just arrow through that and enter in our numbers. So we have, make sure you are using the negative for -1, not a subtraction. Those are not the same thing in your calculator. As with like when we were doing our augmented matrices and stuff, I would absolutely encourage you to go back through and make sure you didn't make a typo. Because very honestly, if you just hit the buttons, it's gonna do the work for you. But if you tell it the wrong numbers, it's going to do that work with the wrong numbers and give you the wrong answer. And there's nothing I can do because there's no work to be shown, right? So calculator stuff, we double check. -1, -1, -1, 4, 5, 0, 0, 1, -3. Okay. Good on the entering a matrix. When I want to go back and like find things about my matrix, I have to go back to the matrix menu, which means I'm going to hit my second matrix again. There's not really any other way to go back to that. So second matrix, and it gets us back to that menu. Notice now next to my A, it says 3 by 3 because I just put a 3 by 3 matrix in there, right? All right, now all of these things that we can do with a matrix are going to be under the math menu. So I'm going to arrow to the right and hit math. This first one's asking me to find a determinant, and in our calculators that is noted as DET. So I went back to my matrix menu. I arrowed over to the math menu at the top, and determinant is your first option. So when I select that, oops, shoot, we need to be out of our matrix to do that. Let me go back to that. I was here in my edit, but where I was, it was going to put it as a thing in my matrix. So I need to actually quit out of my matrix and then go back to that menu to pick determinant. I'm sorry. So that where it sets determinant is just on our blank type in numbers screen. Did we all follow that? Second quit to get out of your matrix. Okay, I want the determinant of what I typed into matrix A. Anytime I want to like access a matrix, again, we go back to our matrix menu. So I'm going to hit second matrix. And this time we want to be under the names menu. When I want to just go select matrix A, be under the names menu, highlight the one you want. I only have one typed in right now. So I'm going to highlight 1 and hit enter or 1. And it'll go put matrix A in there. And we're going to go find the determinant of this. And I hit enter, it will do all that work from yesterday, and we get -1. Questions? Would you like to see me click through that one more time real quick? Yes. You will have a graphing calculator part. Yeah, there will be a small section at the end that's a graphing calculator part. Okay, so determinant of A, we now know. The second thing I asked you to do was find your inverse. Our inverse, same thing. We're using A. We already have A typed in there. So what I want to do is I want to go grab matrix A. Again, to go grab matrix A, I hit my second matrix menu and just select under names, matrix A. And then we want to do the inverse, and you actually have a button on your calculator that has that little -1 symbol that means inverse, and that is the same button we've been hitting for matrix, but without the second key, right? So when I hit that, it's going to look just like our page does with a little -1, and then I hit enter, and it will do the inverse for me. Now, depending on your calculator and what type of answers we get at this point, you could have ugly decimals at that point, and we want fractions. So I do want to point out that if at this moment, and this is not going to hurt anything on my calculator right here, but if at this moment you had ugly decimals, watch this option. All I would hit is math 1, and it says that it's going to turn everything into fractions, and I would hit enter again, and it would take all those ugly decimals in my matrix and turn them into pretty fractions, which I didn't have any to give you an example of, but it would do that for you. And it would re-give you a matrix with all fractions in it instead of decimals, okay? So math 1 if you ever need to change decimals into fractions in your matrix answer that you get on your calculator. Questions on finding a determinant or an inverse on our calculators? Okay, I want you guys to try it without me pushing any buttons in front of you. I want you to use this matrix up here. I want you to input this matrix up here into your calculator and find its inverse. Actually, we'll clear that out. You have to type in the second matrix, go over to math, select determinant first, and now go grab your matrix to put in there. So now go second matrix again.
Is this right?
And you turned it into fractions. I don't know. I'm going to go do it up there right now. But that was the correct way to get decimals into fractions. So again, you have to be super careful that you type things in the right way because there is no work for me to see. You either typed it in and hit the right buttons or you did not. I do not. Do you need to run the bathroom? Okay. So go to my matrix menu here. You can just put it into matrix A. We're not using the one from the first page again, or you can put it into matrix B. I don't really care. It's still a 3 by 3. So as I come down here, let's see, it would be 1, 0, 2, negative 1, 2, 3, 1, negative 1, 0. And as always, we're going to step back and double check that. Quit out of this menu. Now, I did see a ton of people around the room going and getting the determinant of this. That's a great way to start because it tells us if there's an inverse, right? It wasn't necessarily the question up here, but a reminder on how we could do that if we were asked to identify the determinant is you go to your math menu first, grab determinant, insert your matrix in your from the names menu. And our determinant came out to be 1, which means there is an inverse. Now, had that been 0 and I went to go do my inverse part right here, go grab my matrix and hit inverse. If this is 0, this will give us an error message. Okay, so there's a little note for you. You go to get an inverse on your calculator and it says error. I would go check that determinant because if it was 0, that's why. And it looks like here is our inverse. 3, negative 2, negative 4. 3, negative 2, negative 5, negative 1, 1, 2. Questions? Doing okay with our calculator stuff so far? All right, this part, very important. I am going to show it to you on the calculator, but you also have this part non-calculator in a smaller version. So being able to do this with a 2 by 2, but the same concept. So this is your last option. I said I was going to give you multiple options of how to solve a system. We wrote them into an augmented matrix and we got to row echelon, right? Here is another option that is what's called a matrix equation and using your multiplicative inverse. So taking your linear system, look at how this works. It's kind of like that augmented matrix where we take the coefficients of our x, y, and z and put them into columns of the coefficients x, y, and z. So this would be all of our coefficients of our x's. This would be all of our coefficients of our y's. And this would be all of our coefficients of our z's. But different than our augmented matrices, it doesn't then have just a line and the constants after it. So notice that there is a variable matrix here. And that variable matrix represents the three variables you saw in the order that you would see them. Why does this work? If I were to go do my matrix multiplication and I did first times first, second times second, third times third, I would get this little equation back. Do you see that? Same thing with our next one, first times first, second times second times third, I would get the second equation back, okay? So we are representing this system in a matrix equation. That's what this is called. And you can do this for a 2 by 2, 3 by 3, all of that. And then your matrix on the right-hand side of your equation is just your constants or what it equaled in your equation, okay? One of your jobs will be to take a system and write this matrix equation. Question so far? So solving this, I want to know what x equals, what y equals, and what z equals. So ultimately, I want to know what this matrix equals. And right now it's 3 letters, x, y, and z. And at the end of this, I wanted to say that matrix x, y, and z equals something, and that something is my answers, okay? So let's talk about how to get to that. Your matrix equation, if I were to represent these matrices as like just letters, matrix A, matrix X being our variables, and matrix B. Thinking about how I would solve this, again, my ultimate goal is I want this to be my answer. I want it to say X equals my matrix X by itself on one side. But the problem is with matrices, there's no such thing as like dividing by a matrix, right? Have we talked about dividing by a matrix? No, that's not a thing. So just like if I were to solve this for X, I could have divided, right? But we have that other option, and that is to multiply by its multiplicative inverse of 1/5, right? Yes, agreed? Same thing, accomplishes the same thing as dividing. Same thing down here. I want to get X by itself. I'm going to have to multiply by the multiplicative inverse, which is what you guys have been finding all morning so far, is just its multiplicative inverse. So what I'm showing is putting it on both sides. I'm multiplying both sides by the multiplicative inverse. If you were to go back to yesterday when we talked about multiplicative inverse, when I take an inverse times a matrix, I get the identity, which is here. And when I take the identity times anything, it does not change that matrix. And so that's why this side will go to X. Now, guys, you don't really need to like know or memorize those steps. That's what's happening. What we need to understand is this part right here, and it's very important that we do that in the correct order, okay? Because again, switching the order of matrices does change our answer. So you must go inverse times B. And it'll be okay, because if you flip that order, the dimensions would not be correct, and it will give you an error message at that point, okay? So it'll kind of show you the correct order in which these should sit, but it should go inverse times B. So when we start here, we're going to come down here. This is how we can get there. But we take the inverse of A times B to get X by itself. Okay. All right. So let's look at doing this process. Look at the directions, first of all, using the inverse of a matrix to solve a system. So we are going to write the matrix equation. A times X equals B. A is going to be the matrix of our coefficients. X is going to be the matrix of our variables, and B is going to be the matrix of our constants. Okay. So filling in A, we've got a 1x, a 0y, and a 2z. For our second equation, we've got a negative 1x, a 2y, and a 3z. And your last equation is a 1x, a -1y, and a 0z. The X matrix will be your three variables, X, Y, Z, because again, if I were to do this matrix multiplication, we'd get back to our equations. And the B matrix is our constants, 6, -5, 6. Questions so far? Solving this is where I want to go, and that is that I want to get X by itself. And to do that, we will take the inverse of matrix A times matrix B. Still good? Okay. Now we go to our calculators. Let me get mine set up again here. So jobs number 1 and 2 is to go type into matrix A, the 3 by 3, and in matrix B, our coefficients, 3 by 1. So we go over to our edit. Our first one that I'm going to call A is going to be that 3 by 3. Nice. It's the same as what I already had in there. And then we need to go back to our matrix menu. So I'm going to second quit out of this. Go back to my matrix menu and enter in matrix B. Go over to my edit menu, but this time I'm going to arrow down so that I have B highlighted because I'm going to enter a second matrix. This one is a 3 by 1. Now, if I enter that and it ends up looking the wrong way, obviously I flipped my numbers. So I would just go back and put in the correct order, the correct dimensions of our matrix. What is this? 6, -5, and 6. Okay, still good. Now that I have those in A and B, we already actually did this work. Here's our inverse of A. I could go do it again. It's the same A that's already in there. Okay, but that's what we're going to be taking is the inverse of A, which is 3, -2, -4, 3, -2, -5, -1, 1, and 2 times matrix B. But we can just type all that in at one time. I actually don't have to pause in the middle and get that inverse unless I'm showing that on my paper, which we actually already got. Guys, I can type this all in at one time. Watch. My inverse of A, I just go get A and hit my inverse button. There's going to be my inverse of A. And I want to multiply times matrix B. So I now go get matrix B. Again, under my names menu, arrow down to B and highlight or hit 2. And that's exactly what I want my calculator to do, right? The inverse of A times B. And all I have to do now is hit enter and it'll do that multiplication for me. And our answer, that matrix X, which is X, Y, and Z, equals, this is our inverse of A times B, 4, -2, 1. Can you see your answers now to that system? X is 4, Y is -2, Z is 1. Questions? Yes. That's exactly, I think, what your quiz question looks like of your calculator, okay? Because it kind of encompasses all of the questions. So yes, that was a good question from Nate, is that would we be asked to do this? This is, I think, like mirror image of your quiz, is that it gives you a system. It asks you to write the matrix equation. It asks you to find the determinant, find the inverse, and solve. All calculator, but you got to show something. Really, what you're solving or what you're showing is A, B is just a number, C, you would write down a matrix, and D, you give me an answer. Okay, so let's look at how exactly we would do this. All right, let's go to our check for understanding together. See if I can make this a little bigger here. Maybe make notes for yourself about how those answers are supposed to look. Starting with part A, when it says write the matrix equation AX equals B, they give you the formatting, right? AX plus B, but you're supposed to show those actual matrices. So let's go to the matrices for that one. Okay, so I'm actually going to write out what matrix A is, what matrix X is, and what matrix B is when it says write the matrix equation AX plus equals B. Okay, so A is our coefficients matrix. X is our variable matrix. And B is our constants. That's all you have to do on part A. You just write out the actual matrices. Part B, we go to our calculator. Part C, we go to our calculator. Part D, we go to our calculator. Okay, gonna let you guys work on that on your calculator while I kind of work up here as well, and then I'll just be around to help. Okay, if you're having any trouble getting those matrices into your calculator, let me know. I'm going to put some answers up here so you can be checking as you go. We didn't get the same answers? Not for the last part? Uh-oh. Did you get the same determinant and inverse? Check matrix B. Okay, determinant should be -1. My inverse is up there, which is question C, and all you're doing is writing down the results of what your calculator tells you, right? So there's no real work to show. And the last thing I'm going to do is solve the equation. When I solve the equation, understand what your answer should be is either the X matrix equals, or you can put them as a 3-variable coordinate, right? I don't care, but that's what you're solving for. And I should get it looks like -2, -3, 2. And if that is not what you are getting, let me know. Okay, before we are done, let me write those answers down here. Before we are done, I do want to point out that we actually kind of did the bigger ones with our calculator, but you really could do this with a smaller set, like a 2x2. If we were to go back to one of our last examples earlier that had a 2x2 system, let's see, let me find one that was on here. Where's a 2x2 system? Like this guy. Okay, we can do a matrix equation and we can solve using an inverse matrix for a 2x2, and we have all the tools to do that by hand. Okay, so this will be on your non-calculator part of your quiz, is to write the matrix equation AX equals B. And again, I would show, oops, the right matrix. But notice my variable matrix just becomes X and Y because that's the only two variables I have, right? So this is how it kind of translates to a smaller matrix or a smaller system. I would then have to go do the work by hand to find the inverse of this, which is what we learned how to do yesterday, right? I know how to find the inverse of a 2x2. I would do that work and multiply it by B, and all of those things I know how to do with this small of matrices. And that is a question that will be on your quiz on the non-calculator part. So I want you to make sure that you do understand how to do this without a calculator, since our topics seem to be all calculator today. 3x3 we absolutely will do on a calculator. Okay? Any questions? All right. Yes. Your assignment today, last time I will tell you this year, my math lab.